Okay, we're ready for the second page of your practice test. And again, if you haven't practiced the problems yet, you should try them first, then come to the video if you need to. Don't do the problem by watching the video only without having tried the problem. You've got to try the problem. Alright, now notice here it says find the sum of the described geometric series. I may have misspoke in the last video because I was talking about how I like the arithmetic sum over the geometric sum, but I was pointing to the geometric term, the nth term. Notice here in the geometric series, the sum of the terms of the geometric sequence, that there's an a sub 1 and that there's an n and an r, but there's no a sub n. This is the guy I was talking about. Even though you've got some arithmetic to do, I like this guy better because I don't need that final term. Alright, so in this case, negative 3 plus 6 minus 12 plus 24 and so on, 9 terms. The signs are alternating. That means your ratio is going to be a negative number. Your ratio in this case, take the first two terms, 6 over negative 3 is negative 2. I need that. I need the first term. I need the negative 2 for r. So I'm going to take the sum of the first 9 terms. That's the first term, negative 3. I wrote it the way you liked it better, this way. 1 minus my ratio, which is negative 2 to the 9th power. Yikes, careful. Calculator. 1 minus a negative 2. So this is negative 3. Now on top I have 1 minus negative 2 to the 9th power is a negative number. It's negative 512. So I'm going to write plus 512 all over 1 minus a negative 2. That's 1 plus 2. That's 3 down there. So I have negative 3 times, looks like 513 over 3. Well, look at this. Can't ask for that to be much better. 3 goes in that once, goes in that negative 1. So this is negative 513 when you add up those first 9 terms. Down here, there are 12 terms because it's going from 1 to 12. If I was going from 0 to 12, there'd be 13 terms. There's 12 terms here from 1 to 12. So what I want to do here is I'm going to first find the first term. I need a sub 1. A sub 1 is what you get out of this. This is called the summand, this part right here. It's the formula from the nth term for a geometric series sequence. This is, you're going to plug 1 in. 1 minus 1 is 0. 3 to the 0 is 1 times a half. I know that a sub 1 is a half. I also know that since this is what's being raised to the power, that my r is 3. So now I'm going to find the first 12. So that is a sub 1, which is 1/2, times 1 minus my ratio, which is 3 to the 12th power. Oh, I didn't bring a calculator. I should have gone back and got one in between videos. And that's all over 1 minus 3. So this is going to be 1/2 times, oh, let's see, the denominator is going to be a negative 2. That I can do. 1 minus 3 to the 12th. That would be like 9 to the 6th. Man, I don't know what that is. 81 to the 3rd. It's a big number. Bring a calculator with you. And according to your teacher's key, if I have not screwed this up, and I don't think I have, you get 132,860. 132,860. Well, I know that's negative up top, so the negatives cancel, so it's positive. That makes sense. I just don't know what 3 to the 12th is. And I don't really want to multiply it all out. Let's see. 9 times 9 times 9 is 729. Times 729, that would be 9 to the 6, so that's what? 1, 8, 6, 2, 65. 8 carry 1, 5, 14. 3 carry 6, 0 carry 2, 51. 1, 4 carry 1, 4 carry 1, 1, 2, 5. So this turns out to be negative, or minus, 521,441. So this is going to be 1/2, here, let me put it over here, 1/2 times This is going to be a negative 521,440 all over a negative 2, so these are going to cancel. So 2 times 2 is 4, so that's 521,440 divided by 4. At least I know it's going to come out evenly because 40 is divisible by 4. So it goes in 1 time, 1 left over goes in 3 times. Hang on a second. 4 goes in that, that's 12, that's 3. Uh-oh, I think I wrote down the wrong number. What do you have? You had 132,860? Maybe I multiplied wrong. I'm going to get something that's a little different. I'm going to get 130,380. I must have multiplied wrong. That or he did. So you can check my work here for me. Make sure that I'm giving you the right work. This is set up right. I just don't know if I made a mistake here in a hurry. 8, 6, 2, 65, 8, 5, 14, 63, 6, 0, 2, 51, 1, 4, carry 1, 4, carry 1, 1. Oh, I forgot to carry 1. Carry 1 here, that's a 3. Yikes, that's a 3. That's a 3. That's a 3. So that's, let's see, 5. Yeah, 1. Yeah, it's this. I can see I screwed up. Bring your calculator with you so you don't make a mistake like I just did. Determine if each infinite geometric series converges or diverges, then find each infinite sum. Well, if it's geometric and if it's infinite, it converges or diverges based on R. Now here's how you find the sum if it converges. But this is only if it converges. You look at the absolute value of the ratio. If it's between 0 and 1, it converges. If it's greater than or equal to 1, it diverges. The ratio is not going to be 0. You're not going to be dividing by 0. So, or anything weird like that. So in this case, I'm going to look at the ratio. Second to the first. So my ratio is 20 over 4, which is 5. Well, that means it's greater than or equal to 1. So this diverges, and since I'm adding just positive numbers, this goes to positive infinity. If I was adding up negative numbers, it'd go to negative infinity. Now I'll try this one. That was fast. My R is equal to the second term over the first term. Well, that's 3/4 if you reduce it. And that means it converges. Now if it converges, I am going, there we go, there's that video. If this thing converges, then I am going to use this formula here to find the sum. The sum is the first term, which is 48, all over 1 minus the ratio, which is 3/4. Now be careful with your fractions here. 1 minus 3/4 is 1/4. And when you divide by 1/4, that's the same as multiplying by the reciprocal. So that's 192. And there's your sum. Alright. Write the first 5 terms of the sequence described. Now this is not quite a recursive definition, but it's good enough because with the recursive they'll give you a sub 1, in this case a sub 0. But that's okay. That means we can find the first 5 terms. We can find a sub 1. A sub 1 is what you get. A sub 1 is when n is 1. When n is 1, this is a sub 0, so this is 1 plus 4 is 5. A sub 2 would be a sub 1 plus 4, so it would be 5 plus 4, this would be 9. A sub 3 would be what you get when you add the second term, the term before it, plus 4, so that'd be 13. A sub 4, adding 4 again, is 17, and a sub 5 is 21. So the first 5 terms are 5, 13, 17, and 21. Okay, so your teacher doesn't count a sub 0 as the first term. Now here's the only one that I thought was a little tricky, and it's not terrible, but it's a little tricky, because you have to see what kind of a sequence you have here, because they want you to write a recursive rule. Now even if you can't think what the change is, you know, is it arithmetic, geometric, what's going on from one term to the next, you can at least write down that the first term, in this case, is 16, because that's part of your recursive definition, or your recursive rule. A sub n, what are they doing from one term to the next? Well, it looks like they're multiplying by 4 each time. That this is geometric. 4 times that is that, 4 times that is that. 4 times 1/16 is 1/4, 4 times 1/4 is 1 all the way through. So whatever the term is before it, they're multiplying it by 4. So how about a sub n minus 1 times 4. A certain type of cell can replicate itself every hour. So that means it doubles. If a petri dish starts with 200 cells, how many cells do you have in 12 hours? So you're starting with 200. This is when t is 0. This is what you're starting with. This is like a sub 0. And then an hour goes by and it doubles. You have 400. This is a sub 1. Then it doubles again. You have 800. This is a sub 2. And so on. And they want to know how many, way out here at a sub 12, how many cells are in the dish. Actually, they don't want just how many cells are in the dish from this. They want to know the grand poobah total. So we've got to add up all of these. So we're actually adding up 13 terms because you're starting with 200, unless they're dying off. So we are actually adding and finding the sum of the first 13 terms. So we are going to count this as our first term, and that would be our 13th term, which happens at 12 hours. So I probably confused you now. Hopefully I have not. I guess if I read the problem before I started working it, it would make more sense. This is how many terms, the doubling effect during that 12th hour. So this is geometric. You can see you're doubling, you're multiplying by 2, r is 2. Here's your first term. Let's go to this guy here, right here. So this is 200 times the quantity of 1 minus 2 to the 13th power. Because this counts. You've got 200 to start with, so you've got to count him as one of the terms. All over 1 minus 2. Holy smokes, 2,000. I didn't have enough arithmetic to do. 1 minus 2 to the 13th. That's 1,000, 2,000, 4,000, 8,192. 8,192 all over negative 1. So this is 200 times, this is negative 8191 all over negative 1. So those cancel. So I have 200 times this. Yikes! So that's 2 zeros. And then 2 times the rest, 8, 3, 16. I hope I did this right. It looks like you've got 1,638,200 cells. Let's see what your teacher says. He better, oh, bad dog. He doesn't count that last, it says after 12 hours. He's wrong. I think I'm right. Okay, he's got a different answer because he only puts a 12 in here. But I think he's forgetting the original 200. How many cells are in the dish? You got to count the original 200. So I think he's incorrect with this. But you can always ask him. I'm going to stick with my answer there. All right, now there's one last problem, and it's a peach. In that I believe, I haven't solved it yet. I just kind of read through it. But I believe you have to solve a system. All right, let's see what we have here. I got to grab the piece of paper because I didn't write it down. Didn't have enough space. All right, it's arithmetic. Remember the formulas. Define the nth term, a sub 1 plus n minus 1 times d. And s sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. They give you that n is 16. That's useful. They give you that a sub n is 15, and they give you that s sub n is negative 120. They want the first 3 terms, right? Well, I need a sub 1, a sub 2, and a sub 3. Well, one thing at a time here. Let's think. All right. A sub n is is 15, so I'm going to go right to here. I know that this is the 16 here, so I have a sub 1 plus 16 minus 1 times my difference, which I do not know, has to equal 15. So I have a sub 1 plus 15d is equal to 15. See, I have an equation with 2 unknowns. Now I have 3 unknowns up here. Or actually, no. I have 2 unknowns here because I know what n is. But a sub n is this. So I got to plug this in here. So that means I'm going to write it down below that S sub n is equal to n over 2 times a sub 1 plus this mess, a sub 1 plus n minus 1 times d, all of that. Now I am finding when n is 16, so S sub 16, which is negative 120, is equal to 16 over 2. Alright, I don't know what a sub 1 is, but I have two of them here. Oh, and I know that this is a 16 here. I'm sorry. Almost messed up big time. So I have 2 a sub 1, and this is 15 plus 15d. So this is 8. And this, by the way, remember, equals negative 120. So I'm going to divide by 8. I could have distributed, but I have 2a sub 1 plus 15d is equal to negative 15. I have this guy, and I have this guy. I'm going to leave this guy the same. This one's a peach. Somebody figures this one out on their own, they're doing okay. And I'm going to take this guy here, I'm going to get the a sub 1s to cancel. Actually, I could get the d's to cancel. I'll just multiply by negative 1. So if I multiply by negative 1, I get negative a sub 1 minus 15d equals negative 15. Nice. I get a sub 1 is equal to negative 30. Alright, what's my difference here? My difference is, let's go back to this equation. This is negative 30 plus 15d is equal to 15. If I add 30 to both sides, I get 15d equals 45, divide by 15, I get the difference is 3. So that means it's getting 3 bigger because it's positive. So my a sub 1 is negative 30, a sub 2, you add 3, and there's your guy right there. That one's got a little bit to it. Memorize all your formulas, practice your problems.